Starting chapter 7, we're going to talk about the concepts of momentum and impulse. Momentum is probably a word that you've heard pretty commonly in everyday language, like, it's hard to stop something with a lot of momentum, so to speak. So we'll define momentum in a physics context as inertia in motion. So for two things have to be true for something to have momentum. It has to have inertia, in other words, it has to have mass, and it has to be moving. If something is at rest, it has zero momentum. If it's moving, it has momentum. If it has zero mass, it's impossible to have momentum. Okay, so an example of something with momentum would be, you could have like an elephant running, right? Lots of momentum, lots of mass. If it's running, lots of velocity, lots of momentum. Okay? Difficult to stop an elephant that's running, right? Because it has a lot of inertia, meaning it's resistant to change, and then the faster it goes, then the more momentum it has. So if I want to think about calculating momentum, momentum is equal to the mass times the velocity. So back to an elephant running type example, the more mass, the more momentum, the faster it's going, the more momentum, right? So if it's mass times velocity, something that we need to remember then is that momentum is a vector, meaning direction matters. And this will come in to be an important idea when we do collisions and things moving one way and then moving another way. If I calculate momentum, if I write out the equation symbolically, it's P equals mv. So the symbol for momentum is P. I can't use m because m is already used for mass, so I can't have the same symbol represent something different. Its units then are kilogram meters per second. Mass times velocity. Unit for mass is kilogram, unit for velocity is meters per second. So keeping in mind this idea of momentum and inertia and velocity and all that and forces, everything that we've talked about so far, if I think about something with momentum or something without momentum, in order to give something momentum, I have to apply a force. In order to take something's momentum away, I have to apply a force, right? So if momentum is changing, in other words, if something is speeding up or slowing down, assuming that the mass of the object isn't going to change, we're talking about changing in speed, then the object's velocity is changing. Okay? If momentum is changing, then the object's velocity is changing. For this to occur, a force must be applied for a length of time. Okay? A force must be applied for a length of time. In other words, it's impossible to apply a force for 0 seconds. If a force is applied, it had to have been applied for some amount of time, even if it was really quick, even if it was only for 0.03 seconds, right? When a force is applied, it's applied for a length of time. This is called impulse. Okay? So impulse is when a force is applied for a length of time. So if I calculate impulse, It's how much force I apply, how many newtons of force I apply onto something, times the amount of time, the number of seconds I spend applying that force. So the longer I apply a force for, right, the more seconds I spend applying a force, the more I'm able to change the object's momentum. The stronger force I apply, the more I'll be able to change an object's momentum, right? That's the impulse. So an impulse changes momentum. If I write this out, I can write impulse then is equal to force times time. So then the units for that are Newton seconds. Let's think about then what it means to apply an impulse to something. So if I have a bobsled team, in order for someone to apply an impulse to the bobsled to make it start moving, to give it momentum, right, you have to apply a force for a length of time. That's the definition of impulse. So let's think about some common sense here. The harder someone pushes on the sled, in other words, the greater the force, right, that's what I'm talking about, the force that they're pushing the sled with, the faster the sled will be going, right? Faster the sled will be going if a greater and greater force is applied. Okay. Let's think about this then. If someone pushes for more time, so you're applying a certain amount of force, but you can apply it for a long time or you can apply it for just an instant. So this person over here, this person right here, could just quickly push the sled with 1,000 newtons of force, or could push the sled with 1,000 newtons of force for 10 seconds. Which of those two cases do you think is the sled actually going to gain more speed? Well, if you push it for 10 seconds, it's going to get more and more speed the entire time that force is being applied. Okay, so if someone pushes for more time, then the sled will gain more speed. Right? So again, you have this concept of impulse is not just how much force is applied, but it's how much force is applied multiplied by how much time the force is being applied for. The more time you spend pushing the sled, the faster it'll go. The more force you apply to the sled, the faster it'll go. In other words, the more impulse, the more momentum you give the object. The more impulse, the more momentum. So by applying an impulse, you change an object's momentum. If I write that mathematically, it's saying that impulse is equal to change in momentum. So if something has a certain amount of momentum, in order to change that momentum, in order to give it more momentum or take momentum away, an impulse has to be applied. So force times time equals change in, that's my delta, momentum, mass times velocity. And I'll show you in class how this equation is actually just Newton's law rewritten. Maybe you can take a couple minutes and try and see how force times time equals change in momentum is really the same thing as writing F equals ma. So if you think about that and think about what acceleration actually is, you can maybe actually see how this equation is the same as Newton's second law. So let's do an example with a quantitative problem using this idea that an impulse applied changes an object's momentum. So the example is going to be, if you apply a 20 Newton force to pull a wagon for 6 seconds, how much momentum will the wagon have? Okay, so let's scroll down here and make some room to show some work. So if I apply a 20 Newton force for 6 seconds, I know how much impulse I've applied. An impulse is equal to the change in momentum. So if I apply 20 newtons of force for 6 seconds, I've applied a 120 newton second impulse, meaning that is exactly how much momentum I have given the object. The wagon has 120 newton seconds of momentum. Now hopefully you're asking yourself, the unit for momentum we were told is kilogram meters per second. Well, a kilogram meter per second is equal to a newton second. Those two units are the same, they're interchangeable. And again, in class I'll show you why that is, and it goes back to this idea that I said earlier, that impulse equals change in momentum is just Newton's second law kind of rearranged a little bit. So I'm going to add a little bit more to this example and figure out exactly how fast the wagon will be going. So I know how much momentum it has, and now I want to figure out how fast the wagon's going to be going. So in order to figure that out, I need to know how massive the wagon is. So let's say if the wagon is 30 kilograms and starts at rest, how fast will it be going after the 6 seconds? Okay, so now I know that it has 120 Newton seconds of momentum. Well, if I know the mass, I can figure out how fast 30 kilograms must be traveling in order to have 120 units of momentum. So momentum is equal to mass times velocity. I'll just write this out again because that's written up there at the top of the page from earlier. And we wrote that symbolically as P equals mv. So we figured out already that the wagon has 120 Newton seconds of momentum. If the mass is 30 kilograms, you may have already thought to yourself, okay, then the velocity has to be 4 meters per second. So if I have a 30 kilogram mass with a velocity of 4 meters per second, it has 120 units of momentum. All right? So that's the type of problems you'll see on the homework assignment. You'll have questions that you'll have some conceptual questions, but you'll also have some questions that give you information to calculate impulse, and from there, if you know impulse, you can get stuff about momentum, or if you know stuff about momentum, you can figure out stuff about impulse. Okay, so hopefully that was fairly helpful. If you have questions, come to class with questions. Any specifically about the video, let me know, and have a good weekend.